And then this also comes up, so this is related to another thing, so called adjuvants. Now, the whole like anti-vax thing. I mean that this is the evidence for vaccines being safe and effective in preventing epidemics of these diseases is solid. That's why people who are anti-vaccination, they try to move the goalposts and now say, oh, it's not so much the vaccine and the disease, it's all the other stuff we add to it. So adjuvants are chemicals you add to a vaccine to further boost the immune response. So this is why, like especially the polio vaccine and vaccines made with inactivated viruses, sometimes you can inactivate the virus and try to introduce it, and maybe you have an immune response, but it doesn't generate memory B and T cells. So you can get an immune response, but if there's none of those memory T cells and B cells left around, it's useless because you have no record. You start from square one all over again. So what adjuvants try to do is that they try to further ramp up your immune response to increase the chance that you're producing memory T and B cells. And sometimes they help to stabilize the antigens as well. So the things that, and this was one of the other part about the purified protein vaccines. There was an Australian candidate, but they tried to, it was kind of scary, scary too, because like they tried to introduce other parts of other viral proteins to kind of and try to kind of like create a hybrid protein to help stabilize the spike protein, because by itself the spike protein is actually not that stable if you just take the sequence itself. So they tried to add different things and it was causing false positive on HIV tests. And that's like really bad. Like they didn't have HIV, but it was causing false positive when they actually did blood tests. Like these people did not have HIV, but they were testing HIV positive using the tests. So they weren't getting, again, they did not get HIV, but the false positive is why the Australian vaccine that used purified protein, nope, they stopped that. Okay, so then what they do is also help to activate things like your dendritic cells, macrophages, lymphocytes, because the more you ramp up your immune system, the more likely you're going to generate memory T and B cell population. So it's going to promote inflammation and increase immune activity. That's why it's like, yeah, when you get the vaccine, second, especially the second Moderna Pfizer vaccine, you already have those memory T and B cells. So then when you get hit again, that's why that second vaccine typically hits harder, because now you have the memory T and B cells. You get that second exposure to the spike protein. Your memory T and B cells think it's an actual coronavirus. They go crazy. They generate a new population. They cause inflammation. But the good thing is it's generating more of these memory T and B cells. So adjuvants, there's many different types then. There's a broad category. Like it's very interesting. Things like even just simple aluminum or let me look up. So, I mean, you can look up adjuvants, and that's where, and that's probably a big difference between another reason that the Chinese inactivated virus and the Indian inactivated virus vaccines differ, because sometimes I don't know what adjuvants they use. So let's see. Or actually, let's Google that. Yeah, it doesn't list the adjuvants, but common adjuvants. I mean, there are many different types. Like, what are some types? Like, I know aluminum is one type of adjuvant. There's also like sometimes chemicals like oils and squalene. Sometimes they have like saponins as well, and natural compounds like that causes rashes. It would in most people that would cause a rash, but they use a little tiny amount. So they try to use different ways of stimulating your immune system, or sometimes they use things like what else besides aluminum salts? Yeah, there are many different types. That's what. Or sometimes they use like purified bacterial proteins or chemicals. So they're not the actual bacteria itself, but they try to include something that further kind of puts your immune system ramps it up. And what do I have here? Yeah, so let's end with smallpox. So smallpox, this is what we hope for when we create a new vaccine. We want to, so this is smallpox, and oh, that poor child, right? So all these blisters. It was a contagious disease, and basically what they did is they had such a effective vaccination effort against smallpox. It's only there in it's still around, but it's like under a lock and key, under high security in freezers. So smallpox, you haven't heard of it because it was defeated long before it's pretty much extinct in the wild. So this is what the best case scenario, and this is why vaccines are so powerful. If you're able to prevent the pathogen from spreading, you can hopefully eliminate it altogether. I don't know if this is going to happen with coronavirus because it doesn't seem like people are on board with the anti-coronavirus efforts as they were against smallpox. But yeah, that's the whole principle behind that. You want to train your dendritic cells and expose them to the antigen for the pathogen you're trying to defend against. Expose your T cells and B cells and have them train your T cells and B cells so your immune system can create memory T and B cells to fight against future infections. So different vaccines, and again, many different strategy, but the whole purpose of a vaccine, train your immune system before you encounter the real thing. So another analogy I like to use is that vaccines are kind of like study guides or review guides or your own notes. You're trying to train yourself so that when you actually encounter the exam, you're prepared, right? So that's what vaccines are. They're like cheat sheets, they're like exam or review guides before the actual disease, so that when your body encounters the actual pathogen, your body is ready.